Hello everyone, today I want to make a video showcasing how to use NMAP. NMAP is going to be one of your best friends in your penetration testing journey. It essentially is used to map out a network. And it's used to identify services that are running, the current operating system, as well as vulnerabilities that could be on those systems. So you can pass a couple of different targets to NMAP. You can pass it domains, you can pass it a domain in a subnet range, just IP addresses, or even a range of IPs. You can also pass any of these options in a list if you just have a list in the format like I showed below, targets.txt. And if you do nmap-il and then the file name, you can scan those targets. Before nmap actually scans the remote target, the first thing it does is it pings it. And if it doesn't respond, then nmap isn't going to scan it. So to avoid this, like for example, if the network has pings disabled, you can use the pn option so it doesn't perform the ping check and it assumes that it's online. So let's talk about the first scanning technique here, ST. This technique performs a TCP three-way handshake on the target device to determine if the port is either open, closed, or filtered. So if you look at this bottom image right here, and let's assume our attacker is checking to see if port 80 is open on this target PC. The first thing that's going to happen is Nmap is going to send a SYN request to the target machine. If this machine is hosting port 80, it's going to send a SYN ACK response back. And then finally, our attacker machine is going to acknowledge that it's open, take notes of it, and then send an RST packet back to the target machine. The SS option is almost identical to the ST option. However, if you look at the image at the bottom, you can see the RST packet is never sent back, which makes this a bit stealthier and can be useful for avoiding firewalls. When we get to the end here, I'm actually going to show you a lab of comparing a bunch of these different options and their packet sizes. The -SA option is used to help map out firewall rule sets. So we'll get into port states later about what's filtered and open and closed and what that all means. But just think, when you see filtered, it might just be behind a firewall. And so SA is kind of useful for helping determine those firewall rule sets. The -SW option is kind of based off of an exploit in Windows, which allows us to determine if the port is open, closed, or filtered by using the TCP window size. So when we send out packets and we get them back, rather than actually looking in the content, we actually look at the window size to determine if the port is open, closed, or filtered. So all the previous scans we've been talking about only did TCP scanning. So we can use the -SU option to actually scan for services operating over UDP. So this includes DNHS, DHCP. This scan can be very, very slow. So I recommend only really running it on specific targets, not a whole network. You can append this option to any of the previous scans. So if we go back here, and if we wanted to add this option at the end of SA, we could do -SAU, and that will also run the UDP scan. So then we're going to talk about the SN option. This option is useful for trying to perform a stealthy scan on the target system. It doesn't actually send any TCP flags, so it's useful for bypassing some intrusion detection systems and firewalls. So there's a couple of ways you can specify what ports you want to scan. So you can say just a straight port, I only want to scan port 22. You can give it a range. You can say, hey, I want to scan UDP 53, 111 on UDP and TCP, and then 21 through 25 on TCP. It accepts a very broad range of port specifications. You can see at the bottom, I'm telling it to scan Google, scanning the 0 through 5 ports, and then also additionally scanning port 23. So let's talk about port states. So open means an application is accepting TCP connections. There is a service or application running on that port, like a web server or FTP. Closed means the port is accessible, but there's no application listening on it. So it could talk to it, but there's nothing actually on there. Filtered means Nmap couldn't determine whether the port is open or closed. This could be because of firewalls. It could just be confused. Stuff like WAFs or IDS could be preventing this. Unfiltered means the state means that the port is accessible, but Nmap is unable to determine whether it's open or closed. And then closed or filtered is kind of the same thing. It's used when Nmap is unable to determine whether the port is closed or filtered. A super important option for Nmap is -SV. -SV actually enumerates or tries to figure out what version or what software is running this application. So for example, if you look at my screen here, when we nmap Stack Overflow, it just returns as port 80 and port 443 running HTTPS. But if we move over to this other scan here, where we actually patch the SV option, you can see that it was actually able to identify that varnish is behind this HTTP. And Varnish is an actual HTTP reverse proxy. So you can see we found some additional information just by adding this -sv tag. NMAP has this scripting engine, also known as NSE, and this is one of NMAP's most powerful features. So it has several categories of scripts, and you can run any of these categories by using these keywords: auth, broadcast, default, discovery, DOS, exploit, external, fuzzer, intrusive, and more. You can also specify what scripts you want by protocol. So if you look at the image at the bottom here, the NMAP is going to run all HTTP scripts on localhost. -sc runs the default category of scripts. Script update DB updates the script database, and script exploit actively tries to exploit vulnerabilities. So I wouldn't run that on productive machines. Discovery actively tries to query more information to discover more about the network. Vuln, it doesn't actually exploit any of the vulnerabilities, but it only checks to see if they're there. For OS detection, you can use -o or OS scan guess. This will be more aggressive. And another thing I like to throw in there is -a. So this actually enables OS detection, versioning detection, script scanning, and then it performs a trace route. And you can see it can get very specific. It can tell us, hey, it's running Windows 10 from 1809 to 1909. You can increase the speed of NMAP by using the -t option. You can set this from 0 to 5. If you wanted to be more stealthy and send out less packets at once, you would set it to 1 or 2, right? And it would send it out less frequently. But if you send 5, it's just going to spam them pretty much all at once. So let's go over some firewall or some spoofing techniques we can use in NMAP. The -f option is used to fragment each of the larger packets. So it's going to break up all of your packets into smaller pieces and send them over rather than just sending them in one big file or one big packet. The -s is used to spoof your IP address. So if you wanted to make it look like someone else was attacking this device, that's how you would do that. You don't actually get any of the results back since the destination address is changed. But you can spoof your MAC address. So if you set it to 0, it's going to set it to a random MAC address. Otherwise, you can specify specifically what MAC address you want to use. So finally, before we actually get into some of these labs, congratulations if you're still here, we have this ON. So if you wanted to output all of this to just a standard output, just how it normally looks, you would use the ON option. If you wanted to output to XML, let's say you have a tool that might be able to parse this, you would do OX and then the file name. And then you can use OG to output to a greppable format. I'll be showcasing that later. And then you can output in all three of those formats by using OA and then the base name of the file. And then finally, which is kind of an important one, is the verbosity level. So you can update or change the verbosity to get more debugging information about your networking scan, which can be very helpful. So now I'm going to do an Nmap scan on my router, and I'm going to output the results to a greppable file. So I'm going to do Nmap, and then my router IP. I'm going to do OG, and I'm going to name this output.txt. And I'm also going to increase the verbosity by 2. So I'm going to do -VV. So you can see it lets us know that it discovered some ports already. And there's the results of the scan. So if we actually print out the contents of this file, and then if we use the grep command and search for ports, you can see that it shows us what ports it scanned along with what ports were open. And so you can see that if we were scanning a whole network, this would be very useful. So if we could just say, hey, show me the results of this IP address, you would see, okay, it's up, and these are the ports that it has open. That's how the greppable output works. But if we look back up here, I'm going to use this for the sake of the video here. You can see that it has a web service open, it has DNS open, and it has this mysterious port down here open. If we actually go to it, it's another web service here. It has SSH and Telnet filtered, so it could be a firewall that's filtering the results of this, and same with these two. So now I'm going to perform an Nmap scan on my Metasploitable VM. I'm going to use the -F option to specify I want to scan less ports than normal. I'm going to do the -A to tell it I want to do service enumeration. I want to do host enumeration, and I want to perform a trace route. Then I'm going to use the script tag with vuln to say I want to identify any known vulnerabilities that are on this machine. You can use the spacebar at any time to query the status of your scan. Alright, so our Nmap scan is complete here. And you can see we have a bunch of results. Now, this machine that I'm scanning is meant to be very, very vulnerable. It's kind of just meant to be a testing dummy, so this is expected. But I wanted to kind of just show some of the stuff or some of the output you might see. So you can see you have CVE numbers, you have links you can go to for references. It gives you a very detailed description as well. So it tells you what versions, what references you can use, check results. We can keep scrolling up here, and you can see that FTP is open, and it identified the version, it identified some vulnerabilities. Some of these have a score of 10, right, with the tags exploit. It can find interesting URLs for SQLi queries. You can see that it identified it's Apache 2.2.8. And you can see it gets very specific about exactly what is running. I think if we scroll to the bottom here, what operating system. So it identified it's running Linux 2.6.x, and it identified what versions it might be between. So something we can actually do with the information NMAP provides us is we can copy this version information and we can use it on a tool called Searchsploit. Searchsploit is a built-in tool in Kali Linux that uses the exploit DB database to look up any vulnerabilities. So you can see we did Searchsploit and then the version, and we were able to identify a backdoor vulnerability. Alright, so now I'm going to show you guys what it actually looks like using a couple of these different scanning options on the actual machine in Wireshark. So on my actual computer here in this terminal, this is my .76 address. So I have a filter right now to only filter traffic between my host computer, which is this .76, and this actual VM, which is .25. So what I'm going to do is I'm going to do nmap-st, and this is the full connect. So whenever we establish a connection over a port, we're going to send that RST packet ending the transmission. So now I'm going to pass in the machine or the IP address of my VM. And if we look back on here, you can see some traffic rolling in. So now I'm going to filter it. So I'm going to filter, hey, only show me traffic coming from my IP address. If we scroll down a little bit, you can see that there is an RST packet being sent from my machine to this VM. The scan's done, so I'm going to save this. Stop, file, and I'm going to save this as ST. Now I'm going to clear it. Same thing. And now I'm going to do the same scan, but -SS. So now this isn't going to send that last RST packet. And it's already done, so I'm going to stop it. And when you're scrolling through here, you can tell there's none of those red lines. We're not sending those RST packets. So you can tell immediately that it's already a lot faster. So if we go back over here, oh, actually, let me save this real quick. So stop, save, and we're going to save this as SS. If we go back in here, file, new tab, and let's do WC for word count, SS, you can see that there's only 2,102 lines in this file compared to ST, which has 4,000. So you can see that just by using the SS option, which is the default option in NMAP, we're already reducing the size of our scan by half. So now let's use the -SN option. So clear. Let's get rid of this. Nope. Without saving. Do nmap-sn and then the host name or the IP address. It's done. And you can see these are very small, 480 bytes compared to, let's open, let me just open a new one. Can I just do Wireshark? Okay, cool. So 500, 432. You can see if I'm looking at the byte size down here. Actually, we should probably be looking at ip.src. So it's filtered by the ports coming from our actual machine. You can see they're about 528 bytes. So let's compare that to the null scan. And you can see they did decrease a little bit to the 480 side. So that's nice. So let's actually compare these again. So let me save the results on that one. File, save as, SN. And let's do WC. I'm going to stop this one, WC, and then sn.pcap. and you can see that it's 2093 lines, which is slightly smaller than the SS option. So now I want to show you guys what it looks like when using the slowest scan compared to the fastest scan. So I'm just going to do NMAP, and then I'm going to do -F to scan all the fast ports, and then I'm going to do 192.168.0.25, and I'm going to do the speed of 1.
Four to 6 weeks later.
Oh, there's another one. Alright, you get the point. It's pretty slow. So now I'm going to show you T5. It's done. It sent everything at once. I think it literally just sent 206. I remember seeing like these 4 packets. So it sent what? 202 packets in a second. It's pretty good. You can see that it was pretty quick. I've heard of results getting skewed when using such high speed numbers, so and obviously when doing that, you're obviously going to raise a lot of flags when sending that many packets per second. So I hope you guys enjoyed. I hope this was informative. If you guys have any tools you guys want me to look at, I think one of the next ones I'm going to do is Wireshark. If you guys have any tools you want me to look at or make a video on, please let me know.